Today's speaker, I'm pleased to present Professor J. Alex Halderman, who's going to talk to us about the science of election security. Before I give that introduction, I want to spend a moment to encourage you to attend another upcoming event, which is occurring next week. We have our Tao Yu Wu lecturer on Wednesday at 3 o'clock in the Rackham Amphitheater, Wednesday, October 23rd. Dr. Hiroshi Uruguri from Caltech and the University of Tokyo, he'll be talking about constraints on quantum gravity. I encourage you to attend. There is a reception starting at 2:30 on the 4th floor of Rackham, and the lecture will start at 3 p.m. So back to today's event. So we have Professor J. Alex Halderman, the UM Brett Family Professor of Computer Science and Engineering and Director of the Center for Computer Security and Society, and he's going to tell us about the science of election security. Professor Halderman came to us from Princeton University, where he received his PhD a number of years ago. He's the author of more than 100 publications, and his work has been recognized with 9 Best Paper awards. He's helped found 3 security-focused companies, including Let's Encrypt, which protects more than 400 million websites, including the White House and Wikipedia. He received the 2020 University of Michigan President's Award for National and State Leadership, the 2022 Levchin Prize for Real-World Cryptography, and the 2022 Usenix Meta Internet Defense Prize. Professor Halderman is widely recognized as an authority on election cybersecurity. He's done numerous security evaluations of real-world voting systems, both in the US and abroad. He was appointed by Michigan Secretary of State Jocelyn Benson to co-chair the state's Election Security Advisory Commission and has testified twice before Congress about election security threats. He brought a paperless voting machine to Capitol Hill in 2018, and this voting machine was used to demonstrate hacking risks, and it is now in the Henry Ford Museum of American Innovation. In 2019, he was named an Andrew Carnegie Fellow in support of his efforts to strengthen the technological foundations of American democracy. He's the creator of the Securing Digital Democracy, which is a MOOC about computer security and elections that has attracted more than 20,000 students. So I think I've spoken enough, and I will hand this over now to Professor Halderman.
All right, thank you so much. Thank you. It's a real thrill to be here. As an undergrad, physics was my favorite subject, but computer science was easier and I was lazy, so I ended up taking another path. So thank you very much. Election security right now is such a fraught topic. It's very, very difficult to hold a public conversation that is nuanced enough to capture what's really true and known to the scientific community about this issue. And I'm not doing a lot of public speaking this election season because, well, the temperature is already high enough. But I figure in front of an audience that's already scientifically focused, we have the capacity to discuss this issue with the full nuance that it requires. So I beg your indulgence as we launch off into this topic. All right, so first question I want to ask, which of these statements up here on the screen is true? Which of these claims? The former president claiming that Dominion deleted almost 3 million Trump votes in 2020, or the former president's chief of the Cybersecurity and Infrastructure Security Agency declaring that the 2020 election was the most secure in history? Well, there's zero credible evidence for the former president's claim. But the claim from the Cybersecurity and Infrastructure Security Agency is essentially meaningless. And the effect of it is a highly misleading one, because it seems to declare that this is a problem solved. And the truth is that there is a lot of work left to do in election security, even post-2020. And although there certainly have been improvements since 2016, the nation as a whole sort of remains a patchwork of strength and weakness, and it's important for policymakers and the public who elects them to understand where the areas that still need improvement lie. The scientific consensus is reflected very well in this letter that I and about 50 other leading election and security experts published in the wake of the 2020 presidential election. And this was as these claims from the former president and many others that the 2020 vote had been hacked or rigged were flying about. What we as scientists wanted the public to understand was two things. First, that it was and is the consensus of the national academies after doing a years-long study group that there is no realistic method to fully secure electronic vote casting and tabulation from cyber threats. And in fact, we need to turn to non-electronic, non-computer methods to do that. At the same time, that is about possibility, about vulnerability that may exist in future elections. It does not confirm that any particular election has been attacked, has been rigged, of course. And in the case of the 2020 presidential election, well, there was and is no credible evidence whatsoever that the election result in any state was changed through a cyber attack. And at this point, 4 years later, the 2020 presidential result is probably the most scrutinized single electoral contest in American history. And no credible evidence that it was changed through a cyber attack has emerged. So that's where we stand now. Is it possible that cyber incidents could affect future election results? Of course. Is there evidence that the 2020 election result was affected by such an incident? No. So that is the starting point. That is where the scientific community sees election security. And I want to use this hour to help you understand in more detail why both of those things are the case. One very interesting thing to reflect on as we consider our own biases in this question is how public opinion on election trustworthiness has changed following the 2020 election. One of the fascinating things about this is whether people believe that election results are trustworthy depends more than anything else on whether their preferred candidate won the past presidential election. So in the span between 2020 and 2022, this data comes from Pew Research, you can see that trust in elections among Republicans and Democrats swapped. Republicans after 2020 had a low level of confidence in election trustworthiness, but it was exactly as low, or almost exactly as low as that view among Democrats just prior to the 2020 election. So I just find that fascinating, and it's one of the things that makes it most difficult to advance public policy in the election security space, is this kind of whiplash that we have among the public and among, frankly, the policy community every time that power in Washington changes. So consider whether what you believe about elections and trustworthiness is related closely to your partisan affiliation. Okay, so let's take a flashback first and consider some of the evidence that elections really do face serious cybersecurity threats. If you go back to 2016, we have the best documented cyber targeting of American election infrastructure that I can point to. So in 2016, the Russian government undertook a multi-pronged cyber assault on the presidential election. And we know this because of the later investigations of the US intelligence community, the bipartisan investigation of the Senate Intelligence Committee, and the report of the special counsel. And what Russia did in 2016, they really had three prongs to this cyber assault. Right, the first was a series of targeted political leaks, like they hacked into to the Democratic campaign, the Hillary Clinton campaign, specifically to try to steal documents that might be damaging, which Russia then leaked to the public through WikiLeaks. And that consisted of attacks like a phishing attack against John Podesta, Clinton's campaign manager, which targeted his Gmail account. And they basically stole all of his email. And we know it was a phishing attack because among the stolen emails is the phishing email that he fell for, and this is it. It appears to be a message coming from Google that says, someone has your password, you should click here to change it. But when you click there, it doesn't take you to Google. It, in fact, takes you to some site run by the Russian hackers. Podesta, we now know, asked his IT people about this, and one of his assistants wrote back to him saying, this is a legitimate email, John needs to change his password immediately. And the person who sent this, Charles Delavan, today swears up and down that this was a misunderstanding. He meant to say an illegitimate email, John needs to change his password immediately. But the rest is history. The second prong of the Russian attack was on social media through trolling and message amplification, attacks using bots, simulated personalities that attempt to make certain messages look more popular. And the goal, according to our intelligence community, was to try to sow discord and advantage the Trump campaign. This continues to this day. It's ebbed and flowed, the trolling and message amplification on social media. I presume that it continues because it's been somewhat effective at sowing discord among the American public. But the third prong of the Russian attacks, and the one we probably talk about least, but that's most interesting to me as a cybersecurity researcher, was Russia's targeted attacks against election infrastructure, the complex interconnected computer systems that we use to facilitate elections. What we know today, after these investigations, is that Russia targeted the voter registration systems in all 50 states and scanned them, probed them for vulnerabilities that would allow the attackers to break in. We know that in at least 2 states, Russia managed to infiltrate the voter registration databases, and in at least 1, they had the ability to alter or destroy registration data. Now, had they done that, they could have caused extreme chaos on election day if the problem wasn't detected. Simply by scrambling or removing the registration data for people in highly partisan areas of a state or two, they could have caused massive lines. They could have caused voters to just go home who were likely to support a particular candidate. But we know they didn't do this because, well, there wasn't massive chaos on election day in 2016 due to voter registration problems. But it wasn't the technology that stopped them. It wasn't that there were technical hurdles that they couldn't surpass. Ultimately, what stopped them is that Vladimir Putin decided not to pull the trigger. And I think we need to reflect on that fact because it really was that close. And it may well be that close again if we don't take necessary steps to ensure that election systems in all American jurisdictions are well secured. So on the other hand, post-2020, we have, well, stories like this. Have you ever heard that the Obama administration commandeered a powerful supercomputer system known as the Hammer, which includes an exploit application known as Scorecard that is capable of hacking into elections and stealing the vote, according to the CIA? Good. Well, because that, circulated by Dennis Montgomery, is just pure science fiction. Right, that is a conspiracy theory for the ages. You might also have heard things like this. This comes from Sidney Powell, who purported to be an attorney for Donald Trump, that an international communist plot had been engineered by Venezuela, Cuba, China, Hugo Chavez, George Soros, the Clinton Foundation, Antifa, etc., and that Dominion voting systems can set and run an algorithm that probably ran all over the country to take a certain percentage of votes from Trump to Biden. All right, well, there's zero credible evidence for these claims, too. But the interesting thing about these conspiratorial claims, right, I labeled the previous one science fiction for a reason. It's different from utter fantasy. Right, like any good science fiction, I think it was Asimov who said this, that good science fiction starts with physical reality and then just changes one fact. Well, these conspiratorial claims about the election, they're grounded just a little bit in what we know from science. It's not utterly false that voting systems sometimes have security vulnerabilities like other computing systems do. It's not utterly impossible to conceive of any way that someone might try to hack them. So I think they gain strength by being science fiction rather than fantasy. But that doesn't, of course, make them true. So that's where we scientists who are working in the area of election security have really such a difficult time right now, because elections are facing these two very much in tension kinds of risks. The threat of real attacks, as we saw in 2016 from Russia, and the threat of false claims, as were circulated by President Trump and his allies in the wake of his loss in 2020. Both of these sorts of threats are very serious risks for elections, and we may see, or probably will see, attempts at both of them following the election next month. This is what we have to be ready for. But in my view, the best way to combat these false claims is to actually make elections even more worthy of our trust by doing even more to safeguard the real security of elections than we have already. And to do so requires bridging science and public policy to find solutions that are really going to work in the real world. Okay, so the first thing I want to talk about is going to be an incident that happened right here in Michigan in 2020, where one county in Michigan in 2020 really did declare the wrong presidential result. But this is an instance of a pattern we have across the country. In just about every election, there are certain election technology incidents that have always heretofore turned out to be just natural failures, non-malicious. But these kinds of election glitches that do happen, problems with the technology and its administration, are usually very quickly just dismissed and taken out of public conversation. To me, that is a missed opportunity, because in other fields that are highly technical, highly critical, like aviation, right, like aerospace, when an accident happens, an incident happens, we investigate it. We try to determine why, and we try to learn what happened so we can prevent it from happening again. We need to do more of that with election systems. So one of my projects is to try to create models, to create a practice within the election community of rigorously investigating problems that occurred so that we can learn from them. Now, the problem that I want to talk about happened in Antrim County, Michigan in 2020. And on election night in Antrim County, it was reported that the unofficial results had been posted and showed a victory for Joe Biden in this highly Republican county up on the Lower Peninsula. Now, it was only a few hours before the election officials reported that there had been an error and that they were going to correct it. And they posted new corrected results that showed the expected victory for Donald Trump. But the damage had already been done, unfortunately. And you saw it drew a lawsuit from a concerned voter alleging that this was evidence that the entire state's result had been somehow rigged or affected by error. They went before a judge, and the judge up in Antrim County gave this plaintiff and his attorneys the right to do an inspection of the Antrim County equipment. They brought in some very interesting experts who, in a few days, produced a report that declared that the Dominion machines in Antrim County were intentionally and purposefully designed to facilitate error and fraud, and that the whole thing had been rigged, essentially. So this is where this report, we later learned, the ASOG report in Antrim County, we learned from the committee, the Congressional Committee investigating the events of January 6th, that this report was the basis for a draft executive order that was never signed by President Trump, but that would have used the Antrim County incident as a basis for authorizing the military to seize voting machines. So this is what was at stake just right here in Michigan. Okay, so what really happened? In response to the ASOG report, the Michigan Secretary of State and Attorney General tasked me with doing an independent investigation of what happened in Antrim County. I got access to all of the data and the election equipment, and was tasked with basically figuring out what had caused the error, had it been corrected, what can we learn for future elections, was the presidential result right, et cetera. And I did an expert report about that as part of the lawsuit, and now there's a peer-reviewed version of that that was at one of our big conferences in 2022. But I want to tell you what I found, because I think it's really interesting both in terms of how we can use science to affirm an election result and how we can use science to discover grounds or room for improvement. So Antrim County, like all of Michigan, votes on paper ballots. And in Antrim, they use a Dominion voting system where there's a ballot scanner at each precinct. At the county office, they have an administrative computer called an election management system that runs some proprietary software that's responsible for A, preparing the ballot designs before the election, and then B, aggregating the results from all of the different scanners to produce the countywide totals. The scanners need to be programmed with the design of the ballot so they know where to look for the mark for each candidate. And that ballot programming is prepared on the central computer and then distributed by county officials to each of the scanners by using a removable memory card, like the memory card for a digital camera. And that same memory card sits in the scanner and then after the election is brought back to return the election, return the votes for aggregation. The scanners each also produce a printed poll tape. This is like a cash register receipt that says how many votes each candidate got. But the record that's used to produce the official results is the digital one. Okay, so I examined the records from all of these systems to try to make sense of what went wrong. So the first thing that I did is I tried to reconstruct what had happened before the election. The state's initial explanation was that this was a human error during the process of preparing those ballot designs and distributing them to the system. And what I found was, indeed, that something unusual had happened when they were doing the ballot programming. So in September, as usual, they approved the ballot designs, sent them off to be printed, and began to program the scanners. But then in early October, they noticed some errors in certain township ballots. One, for instance, had the wrong school board contest on it. So the election officials went back and prepared new ballot designs, new programming, had those ballots reprinted, and updated that data about the ballot design, the election definition data, but only in 2 of the county's 18 ballot scanners. The rest of them continued to use the original definition. Okay, that ended up causing this massive, massive error on election night. And let me first tell you what the error was and how it happened, and then we can talk about the evidence that it was corrected. So the problem is that when the scanner is programmed with the information about the design of the ballot, internally the Dominion system assigns just a different index number to each possible choice on the ballot across all of the different townships. And when they corrected the school board race, that changed the number of the number of candidates on one of the ballots. It inserted a new candidate or a new write-in blank. This had the effect of shifting all of the later index numbers by 1. They incremented by 1 for all of the later candidates. These index numbers are the only thing that the scanners use to record the vote to the memory card. So a vote recorded with 1 index number, when it's brought back to the central election management system, the vote will be interpreted using the election management system's translation of those numbers back to candidates. Most of Antrim's scanners hadn't been updated after this change to the ballot design, so they were continuing to use the old set of index numbers. The election management system had been updated. It was using the new index numbers. So in most cases, in a lot of the county, they were off by 1. This had the effect of taking the votes for Joe Biden, the first candidate in the presidential race, and throwing them away. Donald Trump, his votes went to Joe Biden. Trump got the Libertarian candidate's votes, and so on down the ballot. But the pattern was relatively complex because of some intervening factors, but if you figure out which precincts were affected by this and just shift the ballots and the votes in the presidential contest, as I show in this diagram, you almost exactly reproduce the error that we saw, and the small residue is explained by certain complexities that I talk about in my report. So this very simple rule undoes the result, and this shows why the errors happened. It was because the election data was updated, but not uniformly across the county. This was a step that the local election official neglected to take. Okay, so that is one way that we can tell what the cause of the problem was. How do we know that the results are now right? Well, with this understanding of what the problem was, we can go back and look at the raw data from the scanners, undo that error by shifting them correctly and comparing them to the official results. And in fact, you get a very, very tight match. You can also count the ballots from the poll tapes that come out of each machine. Each machine's local view of the ballot was unaffected by this problem. So one thing I did, I spent a whole day manually adding up with a calculator the results from those tapes across the entire county, and indeed you get something that very closely matches the final results. Then maybe most importantly, the Bureau of Elections went up to Antrim Township and had people manually count the presidential contest on every single paper ballot across Antrim County, and they get something that's almost exactly the same as the official results too. So on these bases, we can be very sure that Donald Trump won Antrim County by about 4,000 votes. But, and this is why this kind of investigation is very interesting, if you keep going and try to look at all of the Antrim County data, it turns out that there were some other problems that happened. Most importantly, Antrim County didn't just correct the results once. They ended up issuing 5 different sets of election results in November of 2020. The first had the massive error affecting the presidential race. After that, they realized there was a problem. They entered from those poll tapes, from the printouts, they manually entered the results for the townships that were affected and published updated results the next day. The problem is they forgot to delete some of the erroneous results. So some townships were included twice in those totals. So they had to issue another set of results after that on November 6th. Turns out that those results had some typos in them from the manual entries, so they issued another set of results on the 16th, but there were still some typos that they hadn't caught the first time around, so they had to issue another set of results on the 21st. The typos are particularly interesting because they existed in the certified results, and as part of Michigan's certification procedures, we expect those poll tapes to be carefully compared to the official results, but that was not carefully done or was quickly done, and errors affecting about 2.6% of votes across the county were missed. So, okay, after stating the results 5 times, are all the errors corrected? It turns out not. And this was the thing that I was most fascinated by. So, one of the really interesting things, when they changed the ballots to reflect the new design, it turns out that some of the ballots had already been mailed out to mail-in voters. So mail-in voters received 2 different versions of a ballot, an original one and a corrected one. And although there was a mechanism to make sure you only sent back one, once they came back, there wasn't any mechanism in place to tell whether it was the original design or the new design. Some of the targets on those ballots were in different places after the design was changed, and each scanner was either programmed to look for your vote in the original location or the new one. They were just all scanned, mixed together in a batch, so some of those ballots were misinterpreted in every case. That caused some minor errors in down-ballot contests, but fortunately none of those contests was close enough for this kind of error to change the result. But it's still something, it's an administrative error that we need to be more careful to prevent in the future. But there's one contest where there probably was an error that actually changed the result in a very close local contest. And this was the most interesting thing that I think I discovered. So the Central Lake Village Marijuana Retailer Initiative, will we allow a marijuana retailer in Central Lake, was counted twice. Once before they updated the Central Lake scanner with the correct election definition, and then again afterwards. And in the initial scan of these ballots, the result was a tie, so the proposal would have failed. Then they were scanned again, and it ended up winning by 1 vote. 1 ballot disappeared in this process. As far as I can tell, this is probably a human error, and 2 pieces of paper either stuck together or one was left in the scanner. Something happened, because if you go back and look at the data, it does appear that there was 1 more ballot that was distinct from all the others, and it's no longer there when they scan them again. But nobody complained, nobody filed legal papers to challenge this before the deadline. So the legal result is that there is now a marijuana retailer initiative in Central Lake Village, and I went up to see it last summer. There it is. All right, so in the process of doing this wasn't a security review, but I couldn't help but note a number of security problems that are evident from the data in Antrim County. So if you look at how the election management system computer was configured, all different users shared just a single Windows login account. It was a shared account. You couldn't trace it to who was doing the operation. That account had administrator privileges, which would let you bypass any of the other application layer protections or change the log files. There was also a SQL Management Studio application installed that would let you just directly issue database commands and alter the underlying data for the election, skipping all of the different checks and controls that the election software was supposed to be imposing. The Windows security was about 2 years out of date. Fortunately, the computer's not connected to the internet, but still that means there are vulnerabilities that could be exploited by someone with local access that we're not well guarded against. The log files had too small a maximum size, so by the time it was investigated, the log data from election day and the Windows security log had already been purged automatically, and there was no disk encryption. So someone with physical access to the machine could could copy or alter any of the data on it. These are all places that should be improved, but there's no evidence from my examination that any of them were exploited in any way to affect the Antrim County result. Finally, debunking the ASOG report. So remember this truly loony expert report. I've never seen something quite like this in all my career that says the Dominion voting system is purposefully designed with inherent errors to create systemic fraud. The underlying theory is that the scanner generates errors in scanning certain ballots in order to send them to what's called electronic adjudication. Electronic adjudication means that the voter's mark is shown on a screen in front of a panel of election officials and observers, and then election officials can determine the voter's intent. This is a way of trying to increase the scanner's accuracy when voters don't follow instructions and maybe don't fill in the bubble all the way. The scanner can't tell automatically what's happened. But they allege that that was used in order to somehow alter results. Well, there are three problems with this theory. One, adjudication happens after the poll tapes are printed. But we already know that the poll tapes that came out of the scanners exactly match the official results. So this attack would have been too late to have any effect. Two, adjudication is actually very thoroughly logged in many different places. It leaves a very big digital evidence trail. It would be a lousy way to try to alter election results. There are much better ways to cheat if that's your intent. But three, and fatally, adjudication in the Dominion system is an optional feature. You have to buy it separately. Antrim County never did. That's why it wasn't installed and there are no logs for it. They didn't have that capability. So there were just several problems with this theory. All right, so my conclusions about the Antrim County incident, you can read them in my report, but it's basically, we can tell very closely that it's human error, and this is why. And we can learn things, including that the election software should do a much better job trying to prevent election officials from making mistakes, trying to help them. In this case, there wasn't even a warning when the system was importing data that just threw away one of the presidential candidates' results. The software should do a much, much better job of being defensively programmed to ensure accuracy and prevent predictable human errors. And we should do investigations like this after any further incidents, because we may learn things we weren't expecting when trying to understand what went wrong. Okay, so that's an incident that really did happen, where we can go back and figure out it was not a security problem. Now I want to turn to talking about potential security problems that might happen in the future and what we need to do to prevent them. So the consensus of the national academies that I mentioned from their study group is that there's no realistic mechanism to completely prevent cyber threats to casting and tabulation. So this is because election equipment has bugs like other computer systems. It has vulnerabilities like other computer systems. Our challenge in engineering election systems is to use this kind of fallible technology to produce a global result that is trustworthy. So how can we do this? And to understand how, you need to understand a little bit more about how elections are operated today and about what some of the problems, what some of the fallibility in equipment is. So in the US, each state, and sometimes individual counties within states, select their own voting equipment. And across the country, we use about 50 different kinds of voting machines. We also have very close, high-profile national elections sometimes. I just want to go back and look at the 2016 data so you can get a sense of how close this was. Of course, by the popular vote, Hillary Clinton won by about 3 million votes, but that's not how we determined the president. We used the Electoral College. If we look at the Electoral College, we can ask a question about how close was the vote in the Electoral College. And what I want to ask is, what is the smallest number of votes that would need to be changed to alter the Electoral College result? So let's do that minimization problem, and you can do that. And you see it would be sufficient to change about 30,000 votes in just 3 states. That would be the minimal set that would result in an Electoral College tie. So 30,765 of the approximately 137 million ballots cast in this country, that's 0.02% of votes would need to be in error, maliciously or not, to result in minimal fraud. That's how close this was. And 2020 was not much greater a margin by this metric. 2000, of course, was even closer when the presidential election came down to a few hundred votes in one state, Florida. So all of this is to say that when you consider how close margins are in swing states, a potential error or hack attempt wouldn't have to change that many votes in that many places in order to have a material effect on the national result. This causes a great deal of security tension. We need to make sure, especially in the closest states, that everything is as well secured and as accurate as possible. Now let's talk about the equipment that's used to vote and to tabulate, actual voting machines. Up until a few years ago, about half of the country used what are called direct recording electronic voting machines. These are usually touchscreen computers where the main record of your vote is a database entry on some electronic media. Some of them also create a paper trail in the form of usually a continuous roll cash register paper that the voter can briefly see. But you don't have paper ballots, per se, in this direct recording electronic format machine. Nowadays, most votes, about 95% of American votes, are created on different systems, on paper ballot-based systems. In Michigan, we primarily use hand-marked optical scan. This is the most popular system nationwide, about 68% of the country, where the voter fills out the paper ballot like a Scantron test. If you vote in person, you feed this into a machine right in front of you, gets dropped into a ballot box, and there's a database entry of what you voted for. Finally, increasingly, states are adopting what are called ballot marking device-based systems. Ballot marking devices are touchscreens that fill out a ballot for you and print it out. So you can then take it and put it into a ballot scanner. Most of the country where we have paper ballots, ballot marking devices are available for people who request them in case you have some problem filling out a paper ballot by hand. So they're mainly an assistive technology. But in an increasing number of states, they're being used for every voter. This is just how everyone is instructed to vote and fill out their ballot. And this introduces some new security risks I'll talk about in a moment. Many voting systems have now been examined by security researchers, many US voting systems. Optical scanners, DREs, and ballot marking devices. And I'm sorry to say that in every single case where a piece of US election equipment has been examined by credible security experts and they've been allowed to tell the public what they found, among the problems they've found have been ones that could cause vote-altering attacks, essentially in every single case. This is an example. This is from one report that I helped with that was commissioned by the state of California in 2007. This is just part of the index about one of the systems that was examined. And you can see there are all sorts of classic security vulnerabilities. But this machine was about 300,000 lines of C and C++, just far too much code to be secure. If it were fully secure, it would be the first program of that complexity ever to be fully secure. But those are vulnerabilities in individual voting machines. How could those affect a large-scale election? Well, it turns out in most of the country, individual voting machines are not networked, and they're not connected to the internet. That's not true everywhere, but it's true in most jurisdictions now. So how could an attacker try to target them? One answer is that it would be possible in many voting systems, we know from the real vulnerabilities they have, to spread malicious software from the election management system operated by the county to the individual machines as part of that pre-election programming process. So if you can infect the EMS, you can infect the memory cards, and the malware can spread to the individual machines. That could allow someone with insider access or the ability to somehow circumvent the security procedures that the county uses to compromise how votes are recorded over a large area. How hard would that be? Well, in Michigan, about 3/4 of counties use a couple of different small vendors, these are small businesses, to do their pre-election programming. This is the website of one of them from a few years ago. And one thing I just want to point out is that they have this lovely employee directory on their website that gives everyone's name, email address, and photograph. So if you're sitting there in the Kremlin and thinking, well, I want to try to affect votes in Michigan, one thing you might do is try a phishing attack against these service providers and just maybe forge an email from, oh, I don't know, Gary, the vice president, to Larry, the president, asking him to open some spreadsheet. Turns out it's not a spreadsheet, it's malware, and now you're on their network and one step away from the election management system programming 1/4 of the state of Michigan. So that's the kind of worst case scenario I would imagine for election security in a state like this. We've also had cases after 2020 where outsiders affiliated with one of the presidential campaigns talked their way into various election offices in Michigan, in Georgia, in Colorado, and in other states, and got access to those county programming systems and were able to copy all of the data and plug in their own devices to it and so forth. This kind of insider threat or risk of allowing outsiders who may have ill intention to access these critical systems remains one of the things that's most keeping me up at night as we go into 2024. So let me give a quick demo. Who wants to vote on a real DRE voting machine? This is the AccuVote TSX. It was one of the most popular voting machines in the country a few years ago. As recently as 2018, it was still used in 18 states. Today, it's not used anymore. But I want to use it to show you why we've gotten rid of these paperless machines. So who wants to be a voter? Come on down. All right, I need 2 more volunteers. We can get people to line up. Yes. Anyone else? Anyone else? Yes. All right, we have 3 voters. So we're going to do a mock election here. If I can find my voter cards. Well, that's all right. This election isn't going to be fair anyway. He says he's underage. Okay, you can be the first voter. Now, the way this machine works, it's a fancy modern touchscreen machine. So it uses these digital smart cards to authenticate voters. I'll be the election official, give you the first smart card. Take it and put it in, please. This slot is right up here. And if you could just stand a little more towards me so the camera can see what you're doing. Okay, now you can touch next. And here's going to be our contest. President. George Washington or Benedict Arnold, the traitor of the Revolution? All right. All right, and there's your review screen. Just touch Cast Ballot. There we go, and we can take your card out. Thank you for voting. Next voter. All right. Yay! All right. It's going to return your card. Thank you for voting. I should have brought I voted stickers. One more. All right. Whoa. All right. So, thank you very much. So I think we have a victory for George Washington. And let me ask the machine to total up the results. I'm going to put in my administrative key card here and enter my super secret PIN. I'm going to open this door, and here we're going to have a printer that's going to print the poll tape with the election results on it. Oh, thank you. And let's see, it's going to come to life. Come on, come on. Oh, I have to say end voting. User error. Okay, and we're going to get the election results. Okay, so recall that we had 3 votes. George Washington was the winner. We'll see on the document camera here, I think, what the real result, what the result is. Do I have to put? All right, so according to the machine, Benedict Arnold has won. And that's because I've introduced malware into this machine that is changing the record of every vote as it's cast. All of the digital records are within reach of malicious software that's running on it. So I did this very demo on Capitol Hill with Kamala Harris when she was a senator and James Lankford from Oklahoma. And just to educate legislators, that was back in 2018. Today, this machine is no longer used anywhere in the country, and I think that's a great victory. But it was used up until 4 years ago in all of Georgia, and shortly before that, it had been used in all of Maryland and many other places. So what do we learn from that? Well, it's not enough to trust the electronic records from the voting system. This is potentially fallible technology. We need some other kind of record that's going to be able to be reviewed in order to let us verify that the system is operating correctly. So this is where I want to stress, again, there's no credible evidence that this vulnerability has been exploited to change votes in the real world. But how much time do we have until the kinds of sophisticated attackers who showed up in 2016 come back and want to do even more damage? So what can we do to prevent this sort of problem from being exploited? We could try sort of traditional methods of trying to increase our IT security in hopes of keeping attackers away. But unlike in problems like banking, where you know the money is gone, in election systems, if we're just looking at the election output, the totals, we may not know that they are wrong. We can't be sure that our defenses have succeeded. At best, we have no evidence of problems. A better approach, and one that's advocated by just about the entire field of election security research, is to try to engineer elections to generate and check affirmative evidence of the correctness. We can accomplish this by using hand-marked paper ballots and what are called risk-limiting audits, robust audits of those results. So paper ballots, you have a computer scientist saying we should go back and use paper, huh? Am I some kind of Luddite? Well, no. In fact, in any critical system, if we can have a physical fail-safe, that's a very, very useful thing for security. So think about in aviation, right? We have sophisticated satellite-guided navigation, but also by law, planes have to have a magnetic compass in the cockpit in case that system fails. It's a similar thing in voting. If we can have if we can have a paper record of every vote, that can provide a very robust and necessary kind of defense. So paper is inexpensive to, paper too, of course, can be attacked, right? We have a long history in this country of cheating when counting paper ballots or storing paper ballots. That's really well documented. But modern systems produce 2 different records. They produce both a ballot box full of paper ballots and a scan of every ballot, a digital record. So to alter the election result, as long as we're checking that the paper ballots reflect the same outcome as the electronic count, then to change that, you'd have to have a conspiracy that both changed enough pieces of paper and hacked the digital record. That's about as difficult as it could possibly be. But we have to check to make sure they agree. How are we going to do that? Now, I don't think anyone really advocates for a total recount of all of the paper ballots. That would be extremely intensive and time-consuming. But we don't have to do that. So some of the nation's leading statisticians have developed over the past decade and a half techniques for using random sampling to efficiently audit election results. And these are collectively known as risk-limiting audit techniques. So the idea is that you want to examine a large enough sample of the paper ballots to confirm that the electronic outcome matches the outcome you would have gotten by examining all of the paper through a total hand count. And you, with a predetermined, within a predetermined what's called a risk limit, a probability that through just your choice of sample you may have missed outcome-changing error. Now, with a risk-limiting audit, the really interesting thing is if the election is a landslide, you have to just look at a really tiny sample of ballots to confirm that it came out the way it seems. Of course, if it was a tie, you have to go and look at essentially all of the ballots to confirm that it was a tie. So the risk-limiting audit naturally scales depending on the margin of victory that it has been reported for the contest. So it can be really efficient to just do the amount of work you need in order to determine the outcome. The National Academies has recommended that states conduct risk-limiting audits of all federal and statewide contests by 2028. The problem is we're nowhere close to RLAs of all contests by 2028. In fact, I think there are only 2 states so far that require risk-limiting audits of more than one contest. There are only 5 states that require risk-limiting audits of any kind, and only another 8 that are currently piloting them or making them optional. Most states still do what are called traditional audits, where at best they examine a fixed fraction of votes. That's fine if your outcome has a wide enough margin, but if the outcome is a really tight margin, that may not be enough sampling to get a high probability of detecting fraud if it occurred. So we have a problem with not auditing our paper trails rigorously enough. Now, why do we still have this problem? So one interesting thing, over the last 6 or 8 years, Congress has actually provided quite a bit of funding for election security purposes. So there was a tranche, the first tranche in 2018, again. In total, about $1.5 billion in federal grants to the states, which states have used for a lot of different security-related purposes. The issue with this, in my view, is that none of this funding came with any new standards for how states should be securing their elections. And so we've been left with essentially a patchwork of strength and weakness as this money has all been spent. And I think that's best illustrated by what happened to voting machines. So in these maps, this is 2016, and the red is touchscreen DREs like this, paperless machines. Fortunately, they've almost all been gotten rid of. Looking at you, Louisiana, which hasn't yet replaced its system, but only 5% of the country is left using paperless equipment like this. But going back and forth, you can see most of the red has been replaced with these systems that are yellow on my diagram. And the yellow systems are universal use ballot marking devices. So recall that a ballot marking device, instead of filling out a ballot by hand, the voter is using some touchscreen computer to fill out their ballot. Now, the problem with that is that a touchscreen computer is not a pen. It's a potentially vulnerable digital system. And if hacked, it could print out something that's different from what the voters saw on the screen. When BMDs are used by all voters in a jurisdiction, as they are today in Georgia, large parts of Pennsylvania, and elsewhere, well, that becomes a potentially very attractive target. So Georgia's machines that they just bought in 2020, these new Dominion machines. I've been an expert witness in a long-running federal lawsuit in Georgia that's challenged their voting system's constitutionality on security grounds, and the plaintiffs there won the right from the federal courts to do their own security review, which I conducted. That's the first time any current generation voting machine that's on the market now has ever been subjected to an independent, rigorous security review. And the problems that I found, unfortunately, are a lot like the problems that we found in the old paperless systems. There are vulnerabilities that would allow malware to be spread from the election management system to all the BMDs in the field. That can then alter how the ballot is printed out. And in Georgia, the scanners are not counting any part of the ballot you can see. They're just counting a QR code that the machine prints on the ballot that encodes your choices. So if you can get malware onto the machine, it can change that QR code and change how votes are counted. The problems that I found were the subject of a government vulnerability disclosure from CISA to the states back in 2022, and Dominion issued new software. But unfortunately, Georgia hasn't updated. They haven't patched their machines. And worse than that, the Secretary of State of Georgia put out a press release in 2023 saying he wasn't going to patch the problems until after the 2024 presidential election was over. I know, I can't believe it either, right? I mean, it's just dumb to walk around in an alley with $1,000 in your pocket, but it's outright stupid to go on television and say you're going to be there with that $1,000 in your pocket. So they're citing, they say that it's too much expense and work. They don't have the budget to do it before the presidential election or the time. But between the time I found these vulnerabilities and the time Georgia will patch them, will have been longer than the US spent fighting World War II. It's possible for government to move more quickly than that when it's considered a priority. So this is unfortunately what Georgia is going to vote with now. Even if they didn't use barcodes, in a close election, it might well be still a vulnerability to use ballot marking devices for all voters. And that's because the ballots show in text who you voted for, but we're relying on voters to closely examine them and notice any discrepancies and report those or have them fixed. And we don't really know, we haven't known how well voters do that in practice. So my group here at Michigan did a study in 2020 to try to determine that. We set up a mock polling place here in town at the AADL and invited real Michiganders to vote on BMDs that we had hacked to change one vote on each ballot. And we didn't tell the voters that their votes were going to be changed. We just asked them to go through the normal motions. And what we found, and you can read the details and some of the limitations in our paper, but the headline result is that voters missed 93% of errors. So is that enough? They still found about 7% of errors. Well, in a really close election, that may not be enough. The problem is that if the election is as close as, say, the presidential election in Georgia in 2020 was, if voters miss 93% of errors, outcome-changing fraud might occur with only about one report of a problem per precinct, right? One reported error per precinct. And in our study, many of the voters blamed themselves. They said, oh, I must have made a mistake. It printed out the wrong thing. So how you surface that, like, this is the only evidence of an attack, potentially, that you have one voter on average per precinct reporting that the ballot doesn't reflect their choices. How do you aggregate that into understanding that this is a sign of a statewide problem in time to do anything about it? But that's the problem that a Secretary of State might face in a universal use ballot marking device system. Like, you get a low volume of reports consistently across the state. Either this is a bunch of people who have gotten together to make false reports in order to cause problems, or it's a sign that your machines have malware on them and are mismarking ballots deliberately and may have changed the result. which of those theories is right, you have to determine basically right after the election, because the only way to fix it, if the machines have been mismarked ballots, is to throw out the results and ask people to vote again. All the records of the votes are wrong. So I don't envy any political official faced with a choice like this, but I cannot imagine them on the basis of only the little evidence that might surface in a close election, choosing to discard the result. So my recommendation is to use hand-marked paper ballots for as many people as are able to use them. Reserve ballot marking devices for people who need or request them. This is what Michigan does, what most states do, but it's sort of not the trend right now. The trend is to go for these systems. One last problem I want to point out, I know I'm a little bit over, but a new problem that is being posed by modern ballot scanners is a potential threat to voter privacy. So modern scanners, like we use in Michigan and most other states, can record an image of your entire ballot. They aren't just a counter, but they're making a record of each ballot. And increasingly, for transparency reasons, matters of good governance, election officials are making those records public so that anyone can inspect on a ballot-by-ballot basis how election results were obtained. Now, we of course want to protect the secret ballot. It's a very important security protection. But to do that, we need to at least randomly shuffle the ballot records before they're released to the public. Otherwise, it would be easy to identify certain people. The problem that we found in some of this data that's been released by election officials, well, my students and I examined it, and for the Dominion scanners, each ballot is assigned a random-looking record ID. But when you put those IDs together in the right way, they turn out not to be very random. Turns out that the Dominion system, rather than using a proper random number generator, is using something called a linear congruential generator, which has been known since the 1970s to be unsuitable for security purposes. So my grad student was able to just, with pencil and paper, from the public data, reverse engineer what the process of generating these numbers was. And we can now efficiently, for every set of records released from these scanners, unshuffle them and get them back in voted order. The problem with this is that some jurisdictions also make it really easy to find out how people voted in order. So in Georgia, some counties make public through FOIA requests an all-day video of everyone using the scanner. So there we can identify the ballot cast by every voter and link it to video of them using the system. Michigan has patched this problem in its Dominion scanners. Georgia has not, and continues to make vulnerable data public going into November. All right, so what do I score Michigan overall? And I'll end with just one more thought after this. So Michigan's doing pretty well looking across the country. We have paper ballots for essentially every single vote cast in Michigan. The vast majority of those are cast by hand. We also, since 2018, have been doing pilot risk-limiting audits across the state. My main criticism is that those audits haven't been able to happen until long after the election result has been certified. Sometimes into the new year is when they've occurred. So it's too late for them to really correct any errors that are discovered in the result. They'll just give us a bit more confidence or indicate that some serious problem has occurred, but it's too late to correct. So I give Michigan a B+. We should make these audits mandatory. I hope the legislature next year will address some of these issues, extend the audits to be required and to happen prior to certification. But we're very, very close to being at an A level. I'll skip this for time, but there's new work that we're doing in Michigan to try to help with election testing as well. Finally, I just want to remark a little bit about where the candidates stand. We're all going to go and vote. And I'm not going to get political. I don't want to endorse anyone here. But I will point out that Kamala Harris in 2018, as a senator, sponsored a major bill that would have done quite a lot to impose some security requirements on all states in terms of auditing, to provide funds to get rid of all of the paperless equipment and increase election security standards. Since becoming vice president, however, the Biden administration has not done very much on this topic. Donald Trump, of course, has also cited election security problems very prominently. But I'll say that while he was president, his administration is the one that nixed Kamala Harris's election security bill and prevented it from progressing despite bipartisan support. So I would say there are reasons to think that both candidates at least have understood in some way that election security issues are ones that need to be addressed. And the naive part of me hopes that the new administration and new Congress might finally find some bipartisan initiative to address these problems. But this is where you can all laugh at me. All right, so let me leave you with this. Election security is a complex problem, but I think one we can solve through evidence-based methods that will give people greater basis for trust. In particular, making sure that we have paper and it's well audited in a public risk-limiting audit that can give everyone more confidence. So some things to do as a voter. First, make sure you vote. Because if you don't cast your vote, look, the security problems are a potentiality. If you don't vote, you have guaranteed that your vote will not be counted, your voice will not be heard. Two, you can learn more. In the introduction was mentioned my Securing Digital Democracy MOOC from a few years ago. I also have papers on all of these topics available from my website. They're easy to find. Finally, I encourage you to urge the new president, whoever that is, and the new Congress to act on election security reform. We need continued resources to the states and better standards so that we're no longer a patchwork of strength and weakness. Thank you very much.
So we're going to take a few minutes to allow those who are not going to stick around for questions and to vacate. And those who are sticking around for questions, we have questions. Whoops. We encourage questions both from the audience, the live audience, and the virtual audience.
Thank you. Hello. Oh.
Hello. There we go. Yeah.
Yeah.
I wanted to thank you for the talk, and then I also wanted to ask what happened with that sort of like the phony report on what happened to that?
The judge ended up dismissing the case before it proceeded to trial, so it was dismissed. But unfortunately, the experts for the other side in that case ended up leaking some of the data and other information about the system that was supposed to be covered by a protective order, and as a result has, I think, increased the chance that there will be attacks by relatively unsophisticated parties in the future.
Do we have a question on that side?
I know when computing really started, that the companies handling data had databases, employed departments to intentionally find ways to hack into the memory storage and things like that. In the case of elections, are there ever people who were paid to, ahead of time, look into the system, find the little faults, the little holes to go through?
Yes, so that's a great question. This is called penetration testing. And there are really two ways that could be done. One, trying to test the security of a particular deployment, like a county's election office, or to try to test the security of an individual machine, right, of the product. You can do the deployment or the product. I'll say that the Cybersecurity and Infrastructure Security Agency offers some penetration testing services to localities. They can do some security scans or probes of local systems to try to find ways that they could be improved. For the equipment, that kind of testing has not historically been required. There is a movement to start requiring manufacturers to do it for future federal certification, but that is not really in effect yet. One thing to recognize, though, is that the penetration testing depends very highly on the skill of the people involved. So if you're a manufacturer and just trying to find the cheapest penetration testing you can, you might not be getting very much for that investment in the testing if you found people who aren't particularly skilled. The best bang for your buck, like the best companies in the area, though, can do a fantastic job. And in some of the security businesses that I've been involved in, we've gotten a lot of value from that kind of penetration testing. So I would absolutely encourage system vendors to be doing that. It shouldn't be relying on people like me in academia or in our free time to have to find and report problems. Hi.
Yeah, so my question is about human judgment in this process. You know, we can do all the arms races, right, and trying to foolproof technology and trying to penetrate any technology. But in the end, you know, just like when we talk about using all these advanced tools, we need to ground this in reality. How are we training or not training election workers? For example, the Antrim County case, right? Or any case. When you adjust your machine, when you enter new parameters of the machine, do you fill out 200 mock election ballots, enter them in the machine, and make sure, right, the output is exactly what you expect? And when you see an election result, as like the case in the Antrim County, who was the first one who saw the incorrect result and did not realize this was so wrong and published it anyways?
Well, look, so the human element is essential right now, especially the way the systems are engineered. And we should be grateful to our election officials for the hard work that they do to try to ensure quality at every stage. I have some degree of sympathy for the Antrim County error having been overlooked. I elided in the talk that there were some problems with some of the memory cards when they were brought back into Antrim County for a different reason that resulted in the officials having to enter them in manually too. And it wasn't until about 4 in the morning that they finally got to print off that election night result report in Antrim. So I can understand why, as a human being, the Antrim County clerk may not have noticed that the results were badly in error before posting them. She was on the ballot herself, and I don't think even noticed that in her own contest they were so badly wrong. But that I can only think that she must have been totally exhausted by that point. But you also mentioned the pre-election testing, like running mock ballots through. So that's something that virtually every jurisdiction across the country does before every election, is run a certain number of test ballots. It's called logic and accuracy testing. That can provide some security value. In particular, it can potentially help you spot that the machine has been coded with the wrong election definition, as in Antrim County, and things have been swapped around. It can't protect against malware on the machine. because malware can detect that it's under test and just delay. It has a clock. It can know the number of ballots. There are all sorts of ways that it could just wait until testing was done before beginning to cheat. But against more simple attacks, or relatively simple errors like in Antrim County, that testing potentially could be helpful. The problem is that almost all jurisdictions across the country today use testing methods that were developed back in the era of mechanical voting machines, like where there was just a physical odometer-style counter behind each candidate. So about half the country only requires you to test one vote for each candidate. Right? That tells you that the dial is incrementing, but it doesn't tell you if two targets have been swapped. The best testing being performed now in places like Michigan requires a different number of votes for each candidate within a contest during the test. Then you can tell if they're swapped within a contest. The problem is you can't tell if they're swapped across contests. So I've just published some research with a colleague in operations research and one of my students here, in which we've been apparently the first people in 100 years to consider voting machine testing as a mathematical problem. I mean, this is just how sparse this field is. And it turns out that using some techniques from operations research, we can generate efficient sets of test ballots that can detect swaps between contests too, without requiring the tests to be longer than the test that Michigan performs now. So we've been piloting this with the state of Michigan. We're hoping that they're going to roll it out statewide in the near future.
Hello.
Hi.
My question is, when developing malware, I can imagine it's nice to have like the physical machine. Is access to ballot machines like controlled, or can anyone buy it? Do they end up on government surplus sites? And how did you get that machine?
Well, so it used to be that they were easy to get on government surplus sites. This one I bought on eBay. It's a bit harder now, although last year a ballot marking device that was used in part of Michigan, that's the same model used in Georgia, ended up on eBay because a jurisdiction lost track of it, and it ended up being donated to Goodwill and then sold on eBay, and one of my former grad students has it now. So these things still do sometimes leak. The bigger problem to me is that you don't really need the physical machine, you just need the software. And the Dominion software was taken in Coffee County, Georgia, by this group working for associates of the Donald Trump campaign in January of 2021. And it's been floating around amongst certain circles ever since then. So an exact copy of Georgia's election management system and the software for all of their equipment is out there, has been lost, has fallen sort of outside of administrative control. I think for a sophisticated attacker like a foreign government, we just have to assume that they're going to be able to break in and steal software or source code or equipment. But for less sophisticated attackers now, there's a risk because this proprietary software was taken and circulated that they too would have what they would need to exploit it.
What additional risks are presented by mail-in voting, and how can those risks be resolved?
Well, look, so mail-in voting now is the primary method of voting in a number of the big Western states, in California, Oregon, Washington, Colorado. That's how essentially all ballots are voted. And since COVID, it's become even more popular in a lot of the rest of the country. I'll say that it has the advantage that it is a hand-marked ballot, and we now have fairly good tracking through barcodes on your envelope and so forth so that you can know it's gotten back, it's been received. The biggest risks, though, are when you have people voting outside the relative safety of a polling place. I think especially for maybe the most vulnerable in society, there's a substantial risk of people being coerced. So there was a survey in LA County out in California a few years ago that I've heard about, where one of the questions they asked was, did you return your mail-in ballot? And other than yes and no, apparently the most popular answer was something like, I don't know, my husband took it. I think that's probably the most under-recognized risk of mail-in ballots is just the threat of relatively soft coercion of voters. There have been instances where through mail-in ballots have been collected, have been bought, have been fraudulently voted. Those have occasionally been prosecuted, but those are more rare than I think a lot of people think, because usually you need a fairly large conspiracy of people to ballot by ballot affect anything, and there's a substantial risk of being caught and prosecuted. But in terms of just this individual to individual coercion, that does worry me about the expansion of mail-in voting.
This was a great talk. Thank you. Appreciate it. My question is, looking at Antrim County, it seems like there was a lot of IT issues, people having admin rights, people having access to the SQL server. Who's responsible for that? It seems like no one was in charge at all.
Yeah. So generally, that is the responsibility of the election technology vendor, in this case, Dominion. Election officials, it varies from county to county. The larger counties might have dedicated election IT staff. Smaller counties typically will not and will be very reliant on their election equipment vendor for such configuration. In many parts of the country, the exact configuration has to be certified, and you're not allowed to do things like install software patches from Microsoft for the Windows installation unless they've gone through the vendor has taken them through a certification process, which Dominion has neglected to do for really most of the Windows patches that have been released in the time since their election systems were sold. So I think they could be doing a much better job at that.
Before we take the next question, I just want to say that anybody online, if you have questions, you can send them to physics@umich.edu.
Hello. So for ballot marking devices, if one were to be compromised, you sort of demonstrated that most people would not notice. The majority of people wouldn't even tell, and even if they did, they might think it was just their own mistake. But for the small number of people who do, would that be sufficient to raise some red flags and maybe start investigation? Although we can't necessarily recover.
Great question. Yeah. So great question. If a few hundred people in Georgia complain, will there be an investigation? Well, good. Your guess is as good as mine. First, you have to aggregate that, right? You have to realize that it's more complaints than normal. So people have to be complaining loudly enough. And in every election, you have a certain number of people complain that something was wrong, the machine shifted my vote, things of that nature that usually are just the result of human error. So I don't think anyone has a good baseline number for how many complaints there are from ballot marking devices. I've heard anecdotally from election officials that sure, a few people complain now and then that the candidate was in the wrong place, but it was almost certainly them making a mistake. But moreover, I worry about this false flag sort of attack. Right? That if a few hundred people complain, have they all been associating on some internet forum and planning to do this in order to discredit the result, or is it a real problem? And that's the sort of thing you're going to have to decide in close to real time. With Antrim County, I was able to get to the root of the problem, but the investigation took until March in the next year after the election. We don't have that kind of time. Right? You have a few days to make a decision, really, before you're going to start hitting up against hard deadlines in the election code and then in federal law about when the result has to be finished and audited and certified. So I think it's still a tremendously difficult problem.
That does sound difficult.
More questions on this side?
Thank you for the talk. I was wondering, from a technical standpoint, where does an investigation start?
Where does an investigation start? Well, it depends on what happened, right? What do you have in mind?
Where did you start with the Antrim County investigation?
Yeah, well, so with the Antrim County situation, the first thing I wanted to know is chronologically what happened to these machines, right? How were they set up? What configuration was everything in? And then I wanted to know, what does the data actually say at a low level? So I ended up reverse engineering the sort of proprietary binary file formats for everything and looking at it bit by bit, and then putting it back together from there. So I don't know, forensic work is always a bit of a detective story, right? You're trying to find clues about what happened, trying to assemble things in a chronological way, and then trying to come up with the best explanation possible for the observed facts. It's a lot of fun. It's a lot of fun to do that kind of investigation, and I think the hardest part is trying to understand why people made mistakes, right? What was in someone's head at the time? And you can find clues to that. And in Antrim County, I found clues in sort of what messages popped up on the screen, what errors had been made in the past in previous elections that may have led someone to mistake a new problem for something that was benign, this kind of normalization of deviance that we've seen in other disaster scenarios. There's a lot more in my Antrim paper and expert report, if you're curious.
On this side.
Hi. So my question goes to about absentee ballots. I just moved here from Dallas County, and there you have to have cause to get an absentee ballot, and you fill out a little paper that says what your cause is. You mail it to the county election person, and then you're supposed to get a ballot. There's no, there's nothing that you can like look at that says you requested it, that they received your request, that they've sent you a ballot, any of that. So 2 years ago, my parents who requested both got their ballots, and they live in town. They just got it for their age. My 2 college-age students, one in Michigan, one in Maryland, did not get their ballots. So is there any concern about that, or are there any initiatives or about having some sort of system required, or?
Well, so a lot of states do now have good online tracking systems for ballots that are in the mail, and you can find out, you can put in some number you get when you request the ballot or your voter ID number, and you can find out, has it been sent? Sometimes you can track it through the mail. Where is your returned ballot in the mail? Has it been received? Has it been accepted? So a lot of jurisdictions do have that kind of online tracking service for your mail-in ballot now, but not all do, and there isn't any sort of national requirement for it. It's very difficult to make any statement that's true universally about US elections, except maybe this one. I can't say that that's something that Dallas County has now, but it's something that I think Washington County probably does. Is that right? Throughout Michigan, thank you. Constitutionally required to have that, yeah.
And sorry, just a quick follow-up from Dallas County. We had the machines where you use little, use your finger or actually little thing to vote with, and then it prints out in the tiniest font what you voted for, and then has the little barcode on the bottom. But the interesting thing to me was the voting officials weren't allowed to give you that piece of paper. You had to pick it from a pile. They're all identical, blank pieces of paper. And they're not allowed to touch it, only you can touch it. Is that just theater? I mean, I don't understand why.
You mean, so you pick up a blank ballot, put it into the machine, and it feeds it in. It's probably the ES&S Express Vote system. What kind of ballot marking device? I suppose that's probably so that they can't give you a ballot that's been somehow secretly marked in a way that it can be traced back to you afterwards. So it seems like there's probably a good reason to let you pick out your own ballot from that stack to protect your privacy.
Thank you.
We have a question from online. In relation to the Antrim County issue, whenever changes are made to a ballot, why isn't there a unique code, serial number, on the ballot to show that the questions printed on the ballot do not line up with what the computer code is expecting?
Well, that would be one way to engineer the system, and they probably should have done that, but that's not So the longer answer is that in Antrim, in Antrim, they were trying to salvage as many of the existing printed ballots that they had already paid to have printed as possible. And they didn't, if they had the machine generate had the system generate new coding for all the ballots, it would have generated new coding for all the different ballot styles. They would have had to have everything reprinted. And so there's a way to just change some of the ballots in the Dominion system that lets you circumvent that problem. But in order to use it, you have to update the election definitions programmed into all of the equipment, and it's on you to make sure that that's done correctly. It's sort of a way to bypass some of the checks. The system, when the election official executed this command to regenerate only some of the ballot styles, put up a warning that existing ballot definition data will not be usable. That's a really weird way to phrase it, an unfortunate way to phrase it. It probably should have mentioned that if you do use it, it might result in incorrect election results, right? Rather than that it will be unusable.
Okay, we have one last question here.
With regard to the legal system, I have a lot of questions. Maybe you can answer some of them, or you have even better questions. But if I do something nefarious in Dexter Township, who is responsible for persecuting me, perhaps putting me in prison, and what are the punishments which have been given for falsely collecting ballots and throwing them in the box, or we used to find ballots in Chicago floating in Lake Michigan. So what are the consequences of doing any of these things?
Interfering with elections in any of those ways, cyber or otherwise, is going to be a very serious felony and will be prosecuted. If it's discovered, will be prosecuted by the, I guess through the state police would be the most likely way that it would be investigated in Michigan. If it's interstate, it might be the FBI that's involved and so forth as well. Or if it's in a federal election, maybe the feds will be involved too. But it's a very serious crime, and there have been prosecutions for it, including, what is his name? Matthew DePerno, who was the attorney who represented the Antrim County plaintiff, and then a candidate for state attorney general, I believe is currently under indictment for, or under investigation for, illegal access to election equipment in another county subsequent to that. So even having access that you're not supposed to have as an outside party can be a serious crime in the state of Michigan. So these things are policed. I worry, however, that that requires discovery of the problem in the first place. And in Georgia, this Antrim County investigation now has resulted in some prosecutions and guilty pleas, but it took the state more than 2 years to discover that that had happened, and they only discovered through third parties that there had been an intrusion. And similarly, nation-state actors, the Russian or Iranian government, may not care if the problem is discovered. Their secondary goal, or maybe even their primary goal, is just to make people fear that the election outcome has been tampered with, and they can accomplish that by being caught, as well as by doing something nefarious in secret. So they may not worry so much about the Michigan State Police.
Okay, go ahead.
Hi. So this is a question by proxy regarding your belief in the credibility of the principle of security through obscurity. Do you believe that encouraging or possibly even mandating by law election technology vendors to publish the source code running on the election tabulation machines or the election management systems, do you think mandating the publication of that code would be useful or a hindrance to election security?
Well, so look, open source software can be a benefit for security because you can get more eyes on it. It can be a way for people who care about it to scrutinize it and to report publicly what they find. I think there would be a lot more investigation of security problems if election systems in general were open source. The difficult thing is when software was developed in secret, or developed in a proprietary way, it has some store of bugs and vulnerabilities that will be discovered all at once if you shift it from being secret to being open. So that's sort of the fundamental problem with security by obscurity is once you lose it, it's gone. Right? You can never go back to being as secure as you were yesterday if your software leaks to the public. And so I would be a little bit hesitant to mandate it, but I think encouraging it, especially for new voting systems, would be a positive step. But in the meantime, the leaking of election system software and configuration information and so forth does present a serious threat because that system was developed with the assumption that the software would remain secret, and it no longer is. You can't go back.
Okay, let's thank our speaker.
Right. Thank you all. Thank you all very much.